Okay, so welcome back, dear students. So now we are moving on with our non-linear first order partial differential equations, and now today we will discuss about the third type. In the previous two videos we have discussed about two types, so today our discussion will be on the third type. So let us give it a name, type 3. Now, how to identify this? So this will be a function of z, p, and q. So in the partial differential equation, you will see z will be there, p will be present, and q also will be present, and there will be no x and y. Okay, so this is how we will identify the equation, the partial differential equation. Okay, now once you identify this type, how to find the solution? So in this, we start with the trial solution where we assume that our z is a function of, let us call it as u. So our function, our z is a function of u, where u has the form x plus a y, where a is some arbitrary constant. Okay, so we will be dealing with this u. Now from this form of u equal to x plus ay, using simple derivative techniques, you can find that p, that is dou u, dou z by dou x. Okay, so actually this p will be equal to dz by du. Okay, you can use the relationship between ordinary derivatives and partial derivatives, and you can reach to this point very easily. Okay, and same way you can also find that q, which is our dou z by dou y, right? So that q will be actually same as a dz over du. Okay, and using these things we will try to solve the questions. Now let us take a question and let us apply whatever we have discussed so far, and it will be very clear. Let us take a question. Question is, find the complete solution let us say the equation is p multiplied by 1 minus q square is equal to q multiplied by 1 minus z. Let us start our solution. Now, do I have type 3? Is this equation of third type? Yes, because we have seen that what is this type? There should be no xy, and I should only have z, p, and q in the differential equation. So looks fine to me. There is no x and y, and I only have p, I have q, and I have z. Okay, so I am convinced that this equation is of first is of the third type, which we are discussing today. Okay. Now, let us start. Okay, so we will start with our u, which is equal to x plus a y, where a is some arbitrary constant. Okay, and we have already written that using this expression we can find that our p will be equal to dz by du, and q will be a times dz by du. And there is one thing which should be clear to you, which you might have observed by now, that okay, I am working with a partial differential equation, and somehow my p has come as a ordinary derivative. So looks like my partial differential equation may at some point get converted to a ordinary differential equation, right? So let us see how this happens. Let us continue and let's see what we get. Okay, now let us start by putting these two values in the given PDE. Okay, so what we get? So from this partial differential equation, I am getting, now let's start putting the values. So P is dz by du multiplied by 1 minus q square. So that will become a square dz by du whole square, right, is equal to, let's go to the right side now, q, that is a dz by du multiplied by 1 minus z. Okay, no problem. So after doing all your cancellation and all, you will get 1 minus a square dz by du whole square is equal to a times 1 minus z. Looks good. And this gives me that 1 minus a plus az is equal to a square dz by du whole square, right? And this gives us that az minus a plus 1 divided by a square is equal to dz by du whole square, right? And when you take the square root of both sides, my equation becomes dz by du is equal to az minus a plus 1 with a square root divided by square root of a square, that will be simply a. So this is what we were discussing, that yes, we started with a partial differential equation, and now at one point of time we have got an ordinary differential equation which we already know how to solve, right? And this ordinary differential equation, if you observe, is of variable separable type. You can take everything with z on one side and you can take everything with u on the other side, right? Which we called as the variable separable equation. So you can write it as 1 over square root of az minus a plus 1 with a dz, and on the right side you will have 1 over a with du, which is a variable separable ordinary differential equation. And if you remember, to find the solution we simply integrate both sides. So let us integrate. So this will give us 1 over square root of az minus a plus 1 dz is equal to 1 by a du. To find the solution, what we will do, we will integrate both sides and some constant of integration c will appear. And moving on, with integration, we will get az minus a plus 1. When you shift it to the numerator, this will become power minus 1 by 2, right? So power minus 1 by 2 plus 1, that will be 1 by 2 divided by 1 by 2, and we have to divide by a also, right? Simple integration, you know how to do that. Right side will be 1 by a, which is simply a constant, okay, and integration of du, that will give you u, plus some constant c, which is the constant of integration. And always remember that our final answer should be in terms of x and y, of course, because you have put u is equal to x plus ay. Okay, so you have to, in the final step, you have to put back the original value of u. Okay, so this will give us az minus a plus 1, power half means square root, divided by a by 2, so 2 we can keep it in the numerator, is equal to 1 by a u, that was x plus a y plus c. So this is basically our required complete solution. Is it a complete solution? Can we say that this is a complete solution? Yes. Why we can say confidently that this is a complete solution? Because it contains only two arbitrary constants, that are a and c. If you want to simplify this solution, we can do this, but I will leave it for you to further simplify this expression and try to write z is equal to something. Okay, So that last part of simplification, I am leaving it to you. You can write the final solution in terms of z. Okay, z is equal to some function of x and y and a and c. Okay, so that you try yourself. Okay, so this is our third type which we have discussed in this video, and I will be back with the next type in the next video. That will be our type 4, where we will discuss singular solution of uh, Clairaut's form. Okay, so that's it for today. Take care, all of you. We will meet in the next video.